Hey Algebra 1 guys, I hope you enjoy this video. I know that the videos online maybe not the most exciting thing with Mr. Harmon. I can't guarantee mine will be either, but at least it's a little bit of familiarity. I'm going to try to get everybody a video here and there. So this is your lesson. His was a little bit long and convoluted, and I don't think that he got to all the points that were as important. And so I'm going to try to do this one for you. Hopefully you're able to check your homework from yesterday on 8.1 with answer key that was provided, because I gave you some of the even numbers. So if you weren't able to do that, make sure you go back, look on RenWeb, find the answer key that I added. You might have to kind of scroll down. It should say Algebra 1 document or something like that. So go ahead and try to find that. And then today we're going to jump into 8.2. We've started a new chapter. So your test on Friday is going to be over both 7.2, 7.4. That's what you did last week on Thursday and Friday. And then 8.1, 2, and 3. And you should see that on RenWeb as well. So all of this stuff here, tomorrow you're just going to do scientific notation. That should be a little bit of review for you guys. All right, so let's jump in. If you have your interactive notebook, I've told some classes we are not going to have an interactive notebook grade. There's just not too simple to get those all turned in, and I think you guys should be able to use them. Might be more beneficial. So if you can, make sure you're just taking good notes. If you're running out of space or paper, don't worry about your table of contents right now. You probably are needing a new one pretty soon. So if you are running out of space, I suggest that you find something else that can all be in one spot. I hope that having started the interactive notebook was helpful for you to realize, hey, having it all in one spot has been really beneficial. So go ahead and try to keep that all in one spot somewhere, wherever you're taking your notes, but I won't necessarily be collecting them. You will be able to use your interactive notebook or any notes on any assessments that you're taking in addition to your book. So do what is best for you in that. All right. Let's just jump right in. If you'll label this as 8.2 quotients, we're going to do a quick little review from what you did yesterday first. Okay. So this is our review right here. Remember, if you have the same base, in this case it's an x, and they have exponents, instead of multiplying them, we're just going to add them together. Okay? And if you have parentheses around them, you're going to multiply those exponents together. I do want to point out real quickly that this is not the same thing as this. You may want to put this in your notes too. If your negative sign is inside, then everything inside here gets taken to the power of b. If your exponents, or if you're negative, let's say, let me erase that, put it in a little bit more clearly. If your negative is outside of the parentheses, you do all of the exponent work and then just take the opposite of it. Okay, these are not the same thing. So please note here. Okay, put that in your notes if you don't already have something like that. All right, that was a side note. Got distracted. Okay, let's look over here. I have the same base. So what am I going to do with their exponents? I'm just going to add those together. Okay? Really what's happening is it's, let's see, x squared is the same as x times x. And then I have 4 more x's, right? And 3 more x's. And they're all being multiplied together. So I'm just going to add up however many x's I have. Right? So what does that give me? Get this other color here. X to the 9th power. Good. Okay, now I have y as my common base. I'm just going to multiply their coefficient, or the number that goes with it, because it's really 2 times y, and if I'm multiplying all of these together, I can just multiply them through. And I can't really multiply it by y, so it's going to just stay as some number in the front. 2 times 5 gives me 10. And then anytime there is no power, you can draw your invisible little 1 in there. You can come do it down here too. So y to the nothing, really, is y to the 1. So 1 plus 2 gives me y to the 3rd. Okay, and bear with me on this bad handwriting. I'm struggling to write on a tablet, so hopefully you can read it. Guess you can't ask me if you can't, so I'll try to make it legible for you. Okay, this one here, you're going to multiply, right? We're not adding them together. You're taking some base to a power to another power. All right, so this is going to be c to the 7 times 5, or you obviously don't have to write it out like that, just c to the 35th power. Okay, all right. Last one is a little bit of a doozy here. We are just going to start with what's in parentheses here, and then I know we're multiplying it by this other section here, so they really are going to be multiplied all the way through, but I can't do my multiplication until I do exponents according to the order of operations. Remember, parentheses, exponents, and then multiplication and division from left to right. So let's start inside here. There's nothing I can simplify inside there, so I am just going to take every one of these things to the power of 2. And so I'm going to take -5 and square it. I'm going to take x to the 9th and square it. And then I'm going to take y to the 4th and square it. So we've got to be careful with each one of those steps there. I'm going to take this and put it as 25, right? A negative times a negative is a positive, so I don't need that negative sign anymore. X to the what? Do I add them? Is it 11? No, I got this parenthesis here. I need to multiply them. X to the 18th and y to the 8th. Now multiply by 7, x to the 3rd, y to the 1st. Now I can kind of combine these a little bit better. I have my x's that I'm going to add together. My y's, remember, you have to have the same base, so I can only put those together. It's a little bit like combining like terms, but they're not terms because they're not separated by addition and subtraction symbols. You'll need to just make sure you're multiplying all of these through, and there's the simplest form that you can put it in. So 25 times 7, that should be 25 less than 200, so 175. X to the 18th times x to the 3rd. I could rearrange this whole thing down here if you really wanted. You could say 25 times 7 times 8, x to the 18th times x to the 3rd times y to the 8th times y to the 1st power. Right? Commutative property multiplication, 5 times 4 is the same as 4 times 5. Right? Doesn't matter what order you put them in. Now, can't do that with division and subtraction, but we can right now. Okay, so what do we get? What am I going to do with these two? Do I multiply them still? Now I'm going to add them, right? X to the 21 and y to the 9th. Don't forget about that invisible 1. Okay, how you doing on those? Do you feel like that helped you a little bit from 8.1? I know there's a lot of things to think about. A lot of practice is important with this. If you want to go on to after school help, I think I sent an email out about that. There could be some extra problems to practice. There's lots of games online you could search for, practicing operations with exponents and things like that. Again, there's a lot of rules that I think look fine when you go over them, but the more you do them, the more ingrained it'll be, and it'll become second nature to you. Okay, we got to get it in our muscle memory. All right, some new rules today. Make sure you put these in your interactive notebook. I'm going to actually kind of separate these. There are 4 different things here that we're talking about. I didn't draw a very good line through them. All right, this is our quotient or our division. If I have the same base to some power, I have this. Okay, same base to some power, and the same base to a new power in the denominator of some fraction, that is a quotient. Or I could say I'm dividing, right? You could say x to the power of a divided by x to the b. That's the same thing as this. I'm going to subtract instead of adding their exponents, right? Because if I had x squared over x to the 3rd, that would be the same as x times x over x times x times x. That's going to cancel, that's going to cancel, right? I'm actually subtracting 2 from 3. Make sense? All right, so I'm going to subtract those. If you need to pause this video at any time, if I'm going too fast, go back, try it on your own, and then check with me, okay? All right, so here, we're on to our second one. If you have some power, this is review, and you're not going to find it in this section of the book because it's just review. But I decided to put it in here. Hopefully you can put it back in your notes. If you have some base and the exponent is a negative, you need to just get rid of the negative and put it in the denominator. It's really, really simple. So the same goes for this. Like if I had 1 over x to the negative n, then instead of it being in the denominator, I just move it to the top. So I would have x. I guess that's really 1 times x because this 1 is still here. And then there would be nothing, or just 1 in the denominator. So this would just be x to the power, oh, I forgot my n. That's important. So you can go either way. Anytime you see a negative exponent, just put it in the bottom, and if it's in the top, put it in the, if it's in the top, put it in the bottom. If it's in the bottom, put it in the top. Okay, does any of that make sense a little bit? All right, if you have any exponent that is 0, it doesn't matter what your base is, it will equal 1. Just a rule, something to learn. You could have 1,000, you could have 100,000 to the power of 0 is still 1. Doesn't matter what number you plug in. Okay, and lastly down here, if I have exponent and I have something inside of parentheses, some quotient or something, I can apply that exponent to both the numerator and the denominator. Okay, do we see that here? This n goes for the a and it goes for the b, which would bring us back to this right here. Okay, now this is different because our bases are the same, and down here our bases are different, a and b, so you can't combine them in the same way, but that exponent does apply to both of them. All right, do you have these in your interactive notebook? Now that I've kind of marked it up a little bit, if not, pause this, rewind a little. I guess it's not called rewinding, just go back and make sure those are in there. That'll be really helpful. You can use that on your assessment on Friday. All right, let's try some. I'm going to start by rewriting. When I see this division symbol, I'm going to say, hey, that's really a fraction. So I'm dividing something. I'm just going to rewrite it like this. Okay? Now, if you want, you could write this out as 32 times a times a times a. There are 3 a's, a to the 3rd power. Okay, these are equivalent. We're going to start recognizing this, and you won't have to write it out every time, but those a's are going to cancel. So what was happening? I actually subtracted their exponents, right? Which is what I wanted to do here. I wanted to subtract those exponents, right? So I'm subtracting here. I could say 3 minus, and remember there's always that invisible 1. 3 minus 1 would give me a squared. Okay, so I have a squared and it stays in the numerator. If your it will always stay in the numerator. If the bottom exponent is bigger, you'll end up with a negative, and then in the top, so it could be like a to the negative 3rd here, and then it would end up going into the bottom because it was negative. Okay. All right, and then 4 and 32 can cancel a little bit and gives me just an 8. So what is my answer? 8a squared. Okay, if I wanted to look at it without writing it out like that, I could say that I have 32 divided by 4, which we could say is 8, and multiplying it by a to the 3rd over a, which is really a to the 3 minus 1, which is a to the power of 2. Okay, and again, you still need that 8 with it. That makes sense? Okay, well, let's try some more. Stay with me, get all these examples in your interactive notebook. We kind of have a lot to cover today, so I'm going to go a little bit quickly through them. You can always back up and watch the same one again. Hopefully that will help you. Okay, example 2, let's simplify this. Again, we could write every single one of these out, but let's kind of simplify it a little bit. Let's say 24, and I'm going to have this over a negative 8, right? And I'm going to look for my common base. So here is my x, here is my y, and here is my z. So what's really happening, I have a little invisible 1 there. I'm going to subtract these exponents. It's like x squared over x. This is like y to the 6th over y. And this is like z to the 7th over z to the 5th. Okay, now I can write it a little bit more simply. What does this give me? Negative 3 You could say x to the 2 minus 1, y to the 6 minus what? There's nothing there, so what do I put? A 1, right? Oh, except I copied it wrong. Oops, anybody catch that? You're sitting there waiting for me to catch it. Okay, 6 minus 2. And z to the 7 minus 5. Am I doing that right? Okay. So our final answer is -3. Again, you do not have to write out all of these steps. If you can go straight to here by doing it in your head, you are more than welcome to. But I want you to see the steps. If those help you, you can write them out different ways, whatever you need. Okay? So x and y to the 4th and z squared. And that negative just stays in front, and there's your answer. All right, copy these down. We're going to try these together. I challenge you right now to pause the video and to try these on your own. And then we'll go over them together, okay? Now, when I say write an equivalent expression, that's kind of just simplify it. You don't have to multiply as many things through. But remember our rule that if you have a negative exponent, it moves it to the denominator. That's what you're mostly going to need right here. You're also going to need to apply some of these exponents to the entire expression inside the parentheses. Okay, so pause the video and try this. All right, let's go over these. How do you think you did? Give yourself a score. Okay, so I am going to write my x as, if I have a negative exponent, I don't really want it there. This could really be x over 1, right? Anything could be over 1. So if it's in the numerator, I'm going to move it to the denominator, and this part here becomes 1 over x to the 4th power. And I'm still multiplying it by y squared, which is really in the numerator because it could be over 1. So the most simplified that you could say would be y squared divided by x to the 4th power. How'd you do on that? All right, the next one is fairly similar. The 2 could be like a 2 over 1, right? And my x to the -2 could be over 1 as well. Because I have a negative exponent, I want to move him to the denominator. So I have 2, and then in the denominator, I have x squared. Okay, that is most simplified. Kind of looks a little funny, but that's really okay to have it that way. All right, next one. I need to apply my exponent here to everything inside of it, right? It's almost like a distributive property. So I'm going to rewrite it that way. I'm going to write -3rd to the 3rd power times x, let's say x to the -2 power to the 3rd power. All right? So I know that if I take -3 times, I'm going to have negative times a negative times a negative, which is still negative. 3 times 3 is 9, times 3 is 27, so a -27. And here I have my very generic setup. It looks like this here. What do I, oh, maybe not that one, right here. I'm going to multiply those two, right? Okay, so times x to the -6th power. Can I leave it like that? No, I really don't want to. I want to put this in a denominator. I'm going to move him down. This is a numerator and denominator. You could still have a 1, I suppose. I could have -27 over 1x to the -6 if you want to keep these 1s in here. But really, that's not necessary. Anytime you have a 1 in front of your coefficient, you can eliminate it. So this is your best answer here. Now, your negative symbol could be in front or with the 27. It doesn't really matter. Either one is the same. All right, here's my last one. How'd you guys do on those so far? All right, Nola's cheering you on. Let's see. We are going to apply the exponent to everything first. All right, now this gets a little bit tricky. I'm going to write this part out here. Really, I have -3. How do I give this exponent to it, right? Like, what do I do with that? -3. I'm sorry, not a 1/3. Hey, okay, so we can apply my exponent to both my numerator. Oh, wrong thing. Both my numerator and my denominator. Do you remember that rule? Right here. Apply the numerator and denominator. All right. So I'm going to say that this is a 1 to the negative 2 and a 3 to the negative 2 power. Okay, so, well, I have 1 to the negative 2. If I have a negative exponent, I want to move it to the bottom, and if I have a negative exponent in the bottom, I want to move it to the top. So I'm just going to flip this, okay? And that squared will still be there. So I have 3 squared, it's a positive 2 now, over 1 squared, which gives me 9 over 1, or just 9. Okay? All right, so this part here is 9. This is getting really sloppy in here. Sorry about that. Here's my answer. And now I need to multiply these two exponents. So I'm going to have x, and negative times a negative gives me a positive, which is nice. So 9 times x to the 6th power. All right, that one was hard. All right, so let's rewrite this as division. It says divide all of this by all of this. So I'm going to rewrite it in fractional form. Go ahead and do this with me. All right. Okay, let's kind of set this up. I am going to, again, write it out in all these steps. You do not have to show all of these every single time if you are able to figure it out. Just mentally go for that, but I'm going to walk it out every little bit. Oh, no.
Oh, no.
I wasn't recording? Okay, I'm going to leave that in there because maybe y'all need a good laugh or laughing at me now. The part that you missed was me writing all this out and saying how fun it was going to be to make math all these different colors, right? And then you didn't hear my daughter laugh at me in the background saying that math is so fun, which it is. She has so much to learn. All right, well, here you go. I'll give you a second to write all this out. All I did was kind of spread it out here. Hopefully, the other point that I made was that, hey, maybe you are like noticing something in here as you write this out. Okay. Here we go. Hope I'm recording. So 34 divided by a negative 18. I can't really fully simplify that, but I could divide the numerator and the denominator by 2 and simplify that a little bit. So I'm just going to write that out. Oh, not negative 34, negative 17 over 9. All right. Now, for my x base, I have to subtract these two. This is x to the negative 3rd minus a negative 6. And remember, when you subtract a negative, it's the same as adding. So really, this is a negative 3 plus 6. If you wanted, you could come over here and you could switch it. You could put the numerator in the denominator and get rid of the negative exponent, and then move the denominator up to the numerator. And then you'll end up getting x to the 6 minus 3, which would be x to the 3rd power. Or, in this case, we're going to have x to the negative 3rd plus 6, which is going to be x to the 3rd power. So it doesn't really matter which way you do it. Does that make sense? You can do either way, whichever you like. See how fun math is, right? You just do it how you want. You have so many choices. So fun. Anyways, here we go. Let's keep going with y. Wow. If I have the same thing in the top and the bottom, this is just going to become 1, right? Now, if you want to say 2 minus 2, you could, and then you'd have y to the 0 power, and we know that anything to the power of 0 is, dun dun dun, 1, right? Here we go. Or you can just say, hey, I noticed that I have the same thing in the numerator and the denominator, and just turn it into a 1, okay? I'm going to leave it like that for now. All right. And z, I'm going to do this the same way here with subtracting, but you can choose to switch your numerator and your denominator if you want to. Up to you. Again, the great choices that come with mathematics. Okay, so let's see. I'm going to leave this the same. I can't do anything with my fraction here. Now I'm going to have x to the 3rd power, and this is just 1. If you want to put in times 1, you can, but anything times 1 is going to be itself, so we're just going to eliminate your y's. There will be no y in our answer. And z to what? Now remember, this turns into addition, so I'm going to have to the negative 3rd power. So I'm almost done, but I don't like that being in the numerator with a negative exponent. I'm going to move him to the denominator. So my final answer is going to be 17 times x to the third power. Those are all the things that are in the numerators. And now in the denominator, I'm going to have 9 times z to the third power. And there you go. That's as far as you can go. All right, let's keep rolling. We have a lot to cover. You guys are hanging in there. 3 more. You can do it. All right. Here we go. Let's simplify some things here. All right, let me give you a minute to write this one down. And let's just jump right in. I'm going to simplify this as much as we can, just like the other ones. Okay, so this first part, I recognize that I have an exponent with a fraction. So that exponent applies to both the numerator and the denominator. So I'm really going to have, actually let's do it this way. Let's do y. Remember there's an invisible little 1 right there. If you want to write that in, you go for it. You will not be wrong. Okay, so there's my numerator, and x squared is also to the power of 3 in my denominator. Okay, times x to the third. Remember this exponent is also applied to everything inside. It's a way of kind of the distributive property for exponents. To the power of 2 times y to the negative fourth to the power of 2. Okay, so I've kind of distributed those things. Let's simplify it a little bit more. Now I'm going to have to multiply these two together. So that just stays y to the third over x to the sixth. And again, this could be in a numerator. The whole thing is multiplication, so you can put it all together. Every time it's multiplication, there are no terms separating it. Terms are divided by subtraction and addition symbols. All right, this gives me x to the sixth over 1 times y to the what? Negative eighth, right, over 1. I don't like him up there. I'm going to move him to the denominator. So let's kind of simplify this and put it all into one fraction. My numerator still has y to the third and x to the sixth. And then I have x to the sixth and y to the eighth in the denominator. And I am almost there. But actually, I don't really have to do it because it's going to cancel. But you usually put all of your terms, or I guess they're not terms, they're letters in alphabetical order. So I would really prefer that to be switched. I'm going to switch that. I know it seems so insignificant, but I'm going to switch it. All right. What did I have now? I forgot. Y to the third. Okay. So look, I've got the same thing here on the top and the bottom. This is still just an x. I know it looks kind of funny. So this is going to eliminate itself. Or you could say x to the 6 minus 6, or x to the power of 0, which is equal to 1. We don't have to write 1 in our fraction. All right, so that's going to be gone. So now I just have y to the third over y to the 8th. So I'm going to subtract these, y to the 3 minus 8. Now this is kind of what I was talking about before. You can leave this in the numerator this way, and you would get y to the negative 5th, but then he's going to go back down to the denominator anyway. So you'll have 1 over y to the 5th. Or you can just look, hey, I'm going to subtract these two numbers. Where is the exponent bigger? If it's bigger, keep the number in the denominator, right? So this is bigger, so y to the 5th is going to be in the denominator. If your numerator were larger, like let's say, for example, we had it like this, y here, the 8 is larger, so I'm still going to subtract 8 minus 3 and get 5, but now it's going to be in the numerator, right? And when the denominator is just 1, you can just leave it like that. Does that make sense a little bit? So that's kind of a trick. But here's your final answer. All right, 2 more. All right, let's simplify this first one. Because this is, I see parentheses here, but the whole thing is multiplication. So there's really, you could drop the parentheses. There's really no need for you to see that that way, but it's something for you to recognize. It'll happen both ways. This 2 is not being distributive to the negative 2. And the negative 2 is not distributed to the negative 2. It's just multiplication here, right? Everything could be multiplied, all the way through that way if you want to look at it like that. So we're going to kind of need to do a little bit of combining here. So let's take my number first, right? We could do it that way. I'm going to have, and we're looking at just the numerator right now, a negative 2 times a negative 3 gives me a positive 6. Actually, let's write it out the same way we did before. Negative 2 times negative 3 over the 12, right? Now, I don't have any x's in my denominator, but I do have an x to the negative 2 power times an x. These are all both over 1, so I can use that up, right? Now I'm going to have my y to the negative 2 and my y to the third. Okay, so I'm kind of trying to keep this together here a little bit. I guess I could have put these together here with my x's, but all right. So this is going to give me a positive 6 on top, which is just going to be 6 over 12, or 1/2, times, now this is going to move to the denominator, right? It's going to be x squared down here, and this is going to be gone. So now I have an x over x squared, which I can still simplify. And this is really y to the negative 2 minus 3. Or I can say, hey, I really just have to move this down to the denominator. Let's do it this way for sake of doing it differently. So I'm going to have just a 1 left. Remember, there's an invisible 1 in front of every term you have. So I'm going to have the y to the third, and I'm still going to have y to the second. So I'm going to have 1/2. This is x1 minus 2, right? So there's going to be, or you can think about it this way, there's 2 on the bottom, 1 on top. I'm just going to eliminate, there's only 1 x left on the bottom. Or x to the negative 1 power, and then move it to the denominator. And y to the 5th. I'm going to have to add those exponents there. Okay, so more simplified would be written this way. All right, you should do a little victory dance because we are on our last one. All right, here we go. Again, this is multiplied, but I see parentheses, so are your flashing lights going off yet? Do you have the big buzzer going off in your head saying, ooh, I need to think about something. I need to recognize what to do. If I have an exponent outside of everything inside the parentheses, this exponent goes to everything inside. So we're going to rewrite it that way. Isn't that exciting? All right. 8 to the x squared. Actually, we can just move that down to the denominator. You want to do that right now? We'll move it down right now. Oops, let's see. See how we can move him down? Y to the z to the third when he's not negative anymore because we moved him to the denominator. Okay, now the reason I could do that is because he's not being affected by that exponent. All right, now I have y to the negative 2nd power times z to the negative 4th times the negative 2nd power. I'm applying this exponent to every different base that I have. So I have 2 to the negative 2nd and x to the 5th times negative 2. Okay, how do we feel about all of that? Applying that negative 2 everywhere. Okay, now we can simplify a little bit more. Sorry, I'm not using any color. Not as exciting right now. All right. Let's just simplify this up a little bit. And then we'll move stuff to the denominator. So a negative times a negative gives me a positive 8 here. And this is going to be, if I have a negative exponent to just a number, I actually can find an actual answer for that. Or I could say that this is going to be needing to be moved up to the numerator. Does that make sense here? This guy has to kind of come up a little bit. So I'm going to put my 2, let's see if I don't really have a lot of space here. Okay. I'm just going to put my 2 squared up here. Okay. I used him up. And x to the negative 10th, right? Do we see that? Okay, now this negative guy I want to move up, and this negative guy I want to move down. So 8 times x squared times 2 to the 2nd power is 4 times z to the 8th power, and then I'm going to move this guy up times x to the 10th. Now if you want, you can cross these all out so you kind of know which ones you've used. Now I have y, and I still have z to the 3rd power, and I need this guy that I've moved down, y squared. All right. Getting there, we're getting there. I still can combine these two a little bit, so I can just make that 8 times 4, or 32. And now I have a couple x's here. So I can make this x squared and x to the 10th power. Remember, this is kind of like having 2 of them and then 10 of them. I'm not going to draw all 10, so I'm adding those together. So x to the 12th and z to the 8th. All over, and then let's go to alphabetical order. We're going to put our y's first. So I have an invisible 1 here, so that's y to the 3rd when I add them. Z to the 3rd. Okay, almost done. I can, because I have this same base right here, I can actually reduce a little bit. So I'm going to need to take z 8 minus 3, or you can say, hey, what's 8 minus 3? Which one is larger? My z is going to stay in my numerator. So I have 32. X to the 12th, 8 minus 3 gives me 5, z to the 5th, all over y to the 3rd power. And there is your answer. You just conquered some intense exponents with quotients and all the things. So way to go. I hope that helps you. I hope you feel ready for your homework. If not, watch this again. Laugh at me not recording things. Who knows what. Make this fun. All right? Well, miss you guys. Can't wait to do another video for you all. Send me an email saying hi, what you're doing, all that jazz. Nola and Jet, you want to say bye?
Bye.
Miss you all. Bye.